Good morning, everyone. This is David Brott with Tessman Company, General Manager. Today we have the distinct pleasure, Dr. Chaz Smith, who's the Director of Marketing at Mountain View Seeds. He's prior to that, he was the Senior Research Agronomist at Peak Plant Genetics, breeding cool season turf grasses and forage grasses, as well as conducting applied research trials on turf grass. Dr. Schmidt received his bachelor's degree in horticulture and a master's in agronomy from the University of Nebraska, and a PhD in plant biology and pathology from Rutgers University. His PhD research focused on the impact of cultural management practices such as soil nutrition and soil pH on anthracnodes, disease severity, and annual bluegrass putting greens. Today he will be talking about management practices for repairing greens and also seed selection and the NTEP ratings, or NTEP. Thank you for joining us.
Thanks for the introduction, Dave. Happy to be with everyone here. I'm originally from the Midwest area, originally from Sioux Falls, South Dakota. So it's great to see some familiar faces on there. And I'm going to embarrass Corey Morgan here. Corey was one of the first superintendents that I worked for in high school. So it's great to see some familiar faces or familiar names on the attendance list here. So with that, we'll get into the webinar here. So we're going to talk about winter kill and recovery. We'll start off talking a little bit about what causes winter kill and the different kind of conditions. Maybe help you predict a little bit whether you think you're going to get winter kill or not this year based on some of the conditions and some of the different ways we can get winter kill. And then we'll move on and talk about management practices and some strategies for reseeding putting greens. But similar approaches will apply to fairway turf and higher cut turf as well. And then finally, because I do work for a seed company, we'll talk a little bit about seed selection and using the NTEP, a couple of different parameters I would look at when looking at selecting that variety to put back into your putting greens. So let's see if we can get this going here. All right, so I think this is a very timely webinar. I was kind of going through the weather yesterday and looking at some of the weather forecasts, and you hear all these ominous terms like bomb cyclone and all that. But basically, there's a big blizzard moving through the upper Midwest. And these are the type of the conditions late in the winter that can cause devastating winter injury when you get these freeze-thaw cycles. Can really cause some significant injury to putting green turf. So with this system moving through, I think it's a very timely webinar to give. So this is kind of a breakdown. Mostly when we think about winter injury, we think about the environment and the climate affecting our putting greens and causing winter injury, but there's actually a lot that goes into winter injury besides just the environment. Our management practices can have an effect on winter injury. So our soil fertility, we'll talk about some studies that I did looking at soil fertility and how that affects winter injury. Drainage is a big one. If you have standing water on putting greens and freeze-thaw cycles, that can cause major issues. And then protectants such as green covers, that type of thing can help with managing low temperature survival or winter kill. Genetics are also very important. The species of grass can influence winter kill. Some species are more tolerant, some are less tolerant. And you even get down to ecotypes or biotypes. When you look at annual bluegrass, you have some ecotypes that are more tolerant of cold temperatures than others. We'll talk about that a little bit more. Obviously, the environment, your location, any kind of microclimates that you have on your golf course. Maybe you're in a shaded area, sunken down by the trees. You can have more winter injury there. You can get abnormal winter conditions that can cause more winter injury. And then diseases are another big one, especially in the northern climates. And then finally, the plant has some influence on your winter injury as well in the cold acclimation process. So they're producing these antifreeze compounds in the plant, preventing them from freezing up. And so cold acclimation is a pretty complex process for full cold acclimation, or the maximum cold acclimation, it usually takes around 3 to 4 weeks at temperatures in the soil and air temperatures just above freezing to get full cold acclimation. So when you get these freeze-thaw cycles, the grass starts to come out of winter and deacclimate, and then when you get a freeze cycle, they're not acclimated to that cold, and that's when you get a lot of the winter injury. So there's a lot of factors going into that, and we'll kind of go through all of these and talk about them individually. So what causes winter kill? There's multiple different things that can cause winter kill on putting greens as well as fairway and higher cut turf. So we'll kind of break them up and talk about each one individually and see possibly which ones can affect you. So the first one, the one you hear a lot about, is crown hydration. This can be a serious problem. Usually happens when you get warm daytime temperatures and you get a rapid thaw of your putting greens, or the surface of your putting greens, typically seen in late winter, and then you get a very rapid freeze after that. So your plants are deacclimating, starting to grow, take water into the cells, and then the rapid freeze is what's causing that crown hydration. And typically it's actually not a freezing of water within the cells, it's actually the rapid movement of water out of the cells, and kind of a dehydration of those cells is what is causing the crown hydration or the winter injury. So it's a little bit of a misnomer there. Another one that's typical in the upper Midwest, I know my time at Nebraska, we saw some desiccation in the winter. This is usually happens on kind of sunny, dry days when the wind is up. You don't have any snow cover protecting the surface, and you get a lot of moisture sucked out of the surface of the putting greens. This one, of all the winter kill, winter injury ones, this one's probably the easiest to manage. Basically, you get a water tank and pull it around and start watering greens. So that one you can actually do something to and be proactive, although I think with the winter we've had in the upper Midwest, this one's probably not as much of a concern. We also have direct low temperature kill, and this varies quite a bit by species. I've got a table on the next slide here where we'll kind of show the differences between species and winter kill. This one's somewhat rare. Typically it's of exposed turf. If you have any kind of snow cover, that provides an insulation and you won't get the direct low temperature kill. So this is open surfaces with very low temperatures when you can get direct low kill. Another concern, probably what a lot of superintendents in your area are concerned about, is this ice sheets that form at the surface. So once you get ice sheets that are over an inch thick, when you're getting into 2-3 inches thick, you begin to get concerned about gas hypoxia or trapping toxic gas under that layer of ice at the surface. This one's a little bit tough to predict. It's a little tough to do anything about. If you go in and start removing ice, you can actually cause more damage because you're exposing that turf surface to really low temperatures. So this one's a little bit tough on how to manage. Maybe try to poke some holes to get some air moving in there. Also look at the ice. If it's very clear ice, it's not very cloudy and very thick, that's maybe an indication that it could be a little bit more hazardous than an ice surface that's real cloudy and has more oxygen within the ice. And finally, we have our snow molds. Snow molds can also cause injury to turf grass. We've got a nice picture over here of some pink snow mold that we saw at Rutgers. Typically, pink snow mold will recover. These were on some research plots, and by midsummer, you see a lot of growth coming back in here. You don't see kill all the way down to the surface. With gray snow molds in the far northern climates where you get more than 30 days of snow cover, gray snow mold can be a problem and wipe out some turf as well. So that's another thing to think about. If you have concerns about this, definitely worth sending in a sample and confirming. And if it's still active, make a fungicide application to check that before you do any management practices to recover from it. So here's a table looking at the relative low temperature tolerance of cool season turfgrass species. So we have our most tolerant on the top here, all the way down to our least tolerant. And then we have our LT50, so that's the lethal temperature for 50% of a population that you're testing. So at what point does half of your samples die? And then a reference from where it was pulled within the literature. So our most tolerant cool season grass appears to be rough-stalk bluegrass. Poa triv is another name for it. Not a very common grass used on golf courses in the north. This is more of a southern grass used for overseeding on putting greens. Creeping bentgrass will be our next most tolerant cool season species. So the lethal temperature is all the way down to -35. So you can see where direct low temperature kill is somewhat rare. We don't get open canopies with that low temperature too often, unless you're really far up north in the Iron Range or that type of area. Colonial bentgrass is also fairly tolerant of low temperatures. And then we move into kind of the main cool season grasses we see. Annual bluegrass is less tolerant than creeping bentgrass. So when you see those two species in a stand on a putting green, typically you'll see winter injury on the annual bluegrass, and the creeping bentgrass will be less affected. And I've got some pictures to kind of illustrate that. Kentucky bluegrass has a very similar low temperature tolerance as annual bluegrass. The one difference we see here is typically we manage Kentucky bluegrass at a higher mowing height, so that turf is going to be less stressed going into the winter, which means you probably will see less winter injury on it. Next is the fine fescues and tall fescue, and then finally perennial ryegrass is going to be our least tolerant of our cool season species to direct low temperature. So here's a picture that I've got from Michelle DaCosta out at UMass. So this was some species testing that they were doing, looking at the tolerance of different species to low temperatures up in UMass here at their research station. They've got long prolonged winters that are very cold, so it's good area to test that. But you can see the winter injury on the perennial ryegrass here is severe, almost killed everything. The annual bluegrass is very spotty. This is where the biotypes or ecotypes come in. You can see some that are still pretty green and vibrant here, whereas some are dead and not looking so good. So there's a great deal of variation within the annual bluegrass. And then we have our velvet bentgrass, which is probably going to respond very similar to creeping bentgrass. Very little winter injury here and looking pretty healthy coming out of winter. So that's just an idea of the range and species from perennial to the bentgrasses there. So it's kind of on opposite ends of the spectrum. And then here's another good picture that we got. This is actually from Sun River, which is near Bend in Oregon here. So they typically have a lot of severe winter injury, and you'll see a lot of these pictures here. If it says Tom Cook in the corner, it usually comes from Sun River. So this is interesting. You can see a couple different things here. First of all, you can see the bentgrass creeping back into some of the dead spots here. So a lot of what survived in here was creeping bentgrass. You also see some different ecotypes or biotypes of annual bluegrass that survived, and then some that died. So you can see quite a bit of variation within a putting green as far as annual bluegrass, whether it survives or dies. And that's just primarily due to the differences in ecotypes. You know, annual bluegrass is a seeded variety, and they continually seed in there, so you're going to get some genetic variation, which will cause these differences in tolerance. So one important thing I think is what's creeping back in here is the bentgrass. So if we're going to come in and repair, we want to think about putting an improved variety in, a bentgrass, and start trying to thin out some of this annual bluegrass. And so this could be a good way to get a jump start on trying to convert some of these greens that are mixed POA, creeping bentgrass, more back to a creeping bentgrass stand. So what went wrong? I know environment has a lot to do with this. There's a lot of things out of our control. But typically grass that dies from winter injury is due to weakened turf going into the winter. So usually the turf that suffers the worst is turf that is in decline going into the winter. So that's one thing to think about and evaluate when we're looking at some of these sites that have winter injury. Some of the main culprits are shade, nutrient imbalance, which we talked about a little bit earlier, and I'll share some of my research that I did on that. Poor drainage is a big one. and one of the reasons why ice sheets form on the surface of turf, and then traffic stress is another big one. So this is a good picture that illustrates a couple different things here. So this is the cleanup pass of the mower here. So we have added traffic stress going into the winter. If you see, it's actually a little low spot here too. So there's a little trough where water holds and forms. So there's probably some poor drainage. And then where you see the green falls off in the front, we have very little winter injury. So this is another indication this is probably a drainage issue. And then you can see from the picture, we also have shade issues because we have a shade coming here. So we have three things going on why this turf weakened and died. So before we make repairs to the green, we need to think about what went wrong and can we improve the environment around the putting green or fairway or tee, whatever the area may be, before we go back in and reseed or resod these areas. So just a couple more pictures to illustrate my point here. So this is a putting green also in Sun River near Bend. You can see the trees around the back. They have severe shade issues on this back half of the green. And you can see coming out of winter, they have a lot of injury back here. And that's probably due to the shade that these trees are causing on the back of the green, causing weakened turf going into the winter, which subsequently caused winter injury. So I mentioned some research we did at Rutgers as well. This is some potassium work that we were doing. So potassium affects winter injury as well. So we were doing research on anthracnose on a putting green out there, and we had some plots that were very deficient in potassium and some plots that were sufficient in potassium. And as we were going into winter, we began to notice that the plots that were deficient in potassium were not going dormant. They stayed kind of a vibrant green color and kept growing late into the season, whereas wherever we had applied potassium, the plants seemed to be hardening off and going through the cold acclimation process. They began to purple. You began to see some of the anthocyanins produced in the plant. So this was curious to us. So we pulled some samples, did some lethal temperature studies on them, and saw a difference in lethal temperatures. And then we had one of the worst winters on record in New Jersey. We had record rainfalls. It was one of the coldest winters in New Jersey. And then coming out of winter, we had this. So this is a picture couple weeks after the snow melt. Initially, you couldn't see too much of a response, but you get a very distinct smell when winter injury is present. It's a decaying organic matter or almost like silage smell that you can smell immediately after the ice melts. And that's usually a good indication that you have a lot of winter injury. So wherever we see all this winter injury here, this is where we were deficient in potassium. And you can actually see it in the rows between plots here where we're getting a lot of winter injury. And then wherever we were sufficient or had adequate potassium, we had almost no winter injury. So this was a pretty surprising response. If you're interested in this and you're managing primarily annual bluegrass putting greens, this article is on Crops Forage and Turfgrass Management. You can access it there. Or if you're really interested, you can send me an email and I'll forward you the article over. It brings up the question of snow mold and potassium. There's been a lot of research both on bent grass and on annual bluegrass and potassium. So some work that Doug Soldat has done at the University of Wisconsin suggests that potassium increases gray snow mold on creeping bent grass. Some work we did at Rutgers and some work that's being done at Oregon State suggests that potassium decreases pink snow mold on annual bluegrass. So it looks like there's a species difference here. So creeping bent grass probably requires less potassium, and you probably want to avoid late season high rate potassium applications for creeping bent grass, whereas annual bluegrass requires more potassium, and you're probably going to want to make some later season applications of potassium to prevent winter injury as well as some snow mold. So something to think about there when you're thinking about your nutrient requirements. It's probably more species specific than what you would think. This is also a way you can manage if you have a mixed stand of creeping bent grass and annual bluegrass, and you kind of want to limit the annual bluegrass in there. You probably want to be on the lower end of potassium as well. So that's kind of why we see winter injury and what causes it. Now we'll move into a little bit of the repair and selection. I'm not usually one to add quotes to presentations, but this is one that I thought was pretty interesting from the USGA, and it kind of hit home from me. So when repairing an area that has been severely damaged by winter kill, it's an opportunity to make improvements that will help avoid future damage. So, you know, don't just go back there and reseed. You know, think about what went wrong and think about how you can fix it. So this is an interesting picture. It just kind of all came together here. So they're obviously reseeding a putting green after some winter injury here. So, you know, they obviously realize they have some tree issues, some shade issues. So they have a tree service out here removing the trees from the back, opening up some air movement and reducing the shade. They've selected a new species. This was probably primarily annual bluegrass before, so they're coming in with a creeping bentgrass that'll tolerate cold a little bit better. And then while they're in here, I assume they probably did some drainage work as well. So they're not just reseeding or resodding, they're doing other things or other management practices to try to improve the playing conditions or the growth conditions for the grass back here. So that's really important when you begin to think about your management or how you're going to approach recovering from winter injury. So first things first, what are we going to do? You know, you have the snowstorm moving out right now. You can't do a lot as far as site prep and getting things ready, but we can do some planning and some soil testing, that type of thing. So the first thing to do would be to pull a core from your putting green if you have not done so already. Once the surface kind of thaws out a little bit, pull a sample out, bring it inside your office and let it sit in the window with some moisture and see if it starts to grow. You can get some leaf dieback, but not necessarily kill the crown, and you can get regrowth from the crown to replace that dead tissue. So just because it looks dead doesn't mean it's always dead. So all these samples here were pulled off our winter kill study, and you can see the majority of them grew back, but there's a few that didn't. So kind of marking and labeling the cores where you pulled from is very important to know which areas are going to struggle and which areas are going to be fine. The other thing is soil testing. We talked about some nutrient issues and how that can influence the winter kill and that type of thing. So if you don't routinely soil test or you haven't soil tested in a while, this might be a good time to get in there and soil test the problematic areas, see if there's any nutrient deficiencies, especially if we're going to go back in here and seed. We want all of our nutrient levels, especially the P and K, to be adequate. And then we can prune trees. So while the ground's still frozen and we know there's issues, we can get in there and prune trees. If you have trees you've been wanting to get rid of for a while, but your membership or your greens committee won't let you remove them or prune them, you can maybe use this as ammunition to say, hey, we're going to lose greens and continue to lose greens if we don't trim these trees. So use this as ammunition to prune trees and thin them back so you get a better growing environment. So prepping the site, now that we've kind of fixed the environmental conditions going around and some of our management of the soils, we want to think about prepping the site. So one of the most important things to do is remove that organic matter and dead tissue at the surface. So this usually involves aggressive aeration, getting in there, pulling a core, backfilling with sand, and or possibly verti-cutting or vertical mowing that area to remove all that dead tissue on the top. So we don't want that dead material to just sit there. It'll form a sealed layer, be very difficult to grow turf through or germinate seed through. It also will become a layer that will bury with sand, and so we don't want an organic layer to be buried in sand and possibly cause issues with layering the profile. So removing that dead tissue and the organic matter is very important. If you don't, you'll end up with a scenario like this. So you can see the line, the dark green areas in between the turf is just dead tissue that has begun to decay. They've been watering this quite a bit, so that has hastened the decay of that tissue. It's began to seal off and form kind of a crust at the surface. And this is very difficult for bent grasses to kind of creep through and grow into. It's also very difficult to get seeds to germinate through. So you see they've come back with needle tines and tried to break it up a little bit, but that's probably not going to be enough. So what I would do in this case is probably core, and probably even come back in with some aggressive vertical mowing, possibly in 2 directions to remove all this material out of here, and then fill back in with seed and sand to kind of dilute out that layer, so we don't get this kind of sealed off layer at the surface. This is also probably an indication of poor drainage issues here, so you may want to think about correcting drainage issues as well. So now we're on to seeding. We've prepped the site. Time to think about seeding and timing. The optimum soil temperature for germination of creeping bentgrass is between 59 and 86 degrees Fahrenheit. So that's optimum when it's going to grow the best. Annual bluegrass tends to be a little bit lower. It is a winter annual, so between 40 and 70. I've also seen numbers slightly higher than that as well, but typically a little bit lower than bentgrass. There is some initial work out there. It hasn't been published, but you can search it online that has showed that newer or improved cultivars have pretty good germination at 50 degrees, so lower than this 59 degrees that I stated before. Some of the older varieties like Pencross, it truly is a 59 degrees. They don't tend to germinate till that point. But some of the newer varieties that you'll see in the NTEP have better germination at lower temperatures. So 50 seems to be kind of the bottom floor. You don't want to go above, below that. And then looking at the different species of bentgrass, creeping and colonial tend to germinate about the same temperature, and they're quicker than the velvet bentgrass. Velvet tends to be a little bit slower. So we're going to shoot for soil temps. On the conservative side, I would look for soil temps consistently in the mid-50s to go in and seed. If you're in low 50s, but you have very favorable weather forecast for the next week or two, maybe pull the trigger if it's a little bit lower temperature. But there's lots of different things out there we can use to measure soil temperatures. So the Field Scout that Spectrum has, I know, gives surface soil temperatures. You can buy cheap soil probes or thermometers you can get online and check soil temperatures routinely. A lot of the weather stations now measure soil temperature. So there's just one thing to monitor and see how your soil temperatures are going. Once you hit that 50-degree mark is kind of when you want to start thinking about, all right, need to get things together and get organized and get ready to get out there and start seeding. So if you want to be more on the conservative side, wait till it gets a little bit higher, closer to that 59 when you hit the optimum condition. So I'm going to talk about 2 different methods to kind of seed and get the seed into the profile. The first one I'm going to talk about is slice seeding or slit seeding, and this is the preferred method. If you have this equipment at your disposal, or if you can rent this equipment, this is definitely the preferred way to go. You get better coverage and quicker fill when you slice seed. We're going to want to calibrate our slice seeder, our slit seeder, to a rate of 1 pound per 1,000 per pass. So each pass will put down 1 pound of seed per 1,000. And the seeding depth we're looking for is right around 3/8 of an inch. So we don't want to get buried too deep into that soil profile. Creeping bentgrass seed is pretty small, so you don't want to bury it too deep. And then when you slit seed, you want to slit seed in 2 directions at a 45-degree angle. You can see that's what we have. The pattern over here that optimizes your coverage of the putting green, and will get it to grow in faster. Once you seed, you want to come back with a light sand top dressing just to make sure you have good soil to seed contact and fill in some of those slit seeding channels or holes. You're going to want to go very light. We don't want to brush it in and move seed around. So if you do need to incorporate the sand, I would water it in, or water it in, let it dry, and then come back with a lightweight roller to roll and smooth the surface. So there's a lot of different products out there, different pieces of equipment you can use. Here's a walk behind slit seeder that I've used before that does a pretty good job, although it's a little bit small. It doesn't cover a lot of area. For the warm season market, they have some slit seeders that go on the back of Workmans, that type of thing, that cover a lot more area. So if you just have areas to patch in the greens, a piece of machine like this may be good. If you have larger areas, you may need a piece of equipment a little bit larger. This is another attachment that I found. This actually attaches to a triplex mower, so this replaces the cutting units. And it's got these little spikers here that are on wheels that'll spike the seed in. It's got a hopper up here to hold the seed, and it drops the seed through these little holes, and it will spike them into the ground. So if you're considering a project to improve the bentgrass on your putting greens and you're going to do a lot of overseeding, maybe this type of unit is something you want to invest in because you want to go out 2-3 times a year and put new bentgrass seed out and try to transition either away from an older bentgrass or away from annual bluegrass. Maybe you would like to invest in a piece of equipment like this so you can continually seed pretty efficient out there and throw some seed down. So the other method that we can use, I understand that's somewhat specialized equipment and not every facility has access to it. So the other method we can use is an aeration verti-cutting method. So we talked about an aggressive aeration before, so we probably want to do an aggressive aeration, come back in, backfill the holes till they're almost full. We don't want to fill up the canopy and get too much up there. And then verti-cut over top of that in 2 different directions, so we're still getting that cross-hatch pattern. Because we're just applying the seed to the surface and hoping it gets into those verti-cutting holes, we're going to want to seed at a higher rate. So a recommended rate for this verti-cutting method is somewhere between 3 to 4 pounds per thousand. We're going to get a lot of death of the seed on the surface because it doesn't have great soil to seed contact, and it's a little bit more exposed at the surface versus being buried into the soil profile. So we'll want to apply a little bit more seed if we do this method. We definitely want a light sand top dressing over the top of that to cover up that seed and protect it a little bit. And then definitely no rolling or definitely no brushing with a broom that will move the sand around too much and move the seed around. So a roll to firm up the surface is all we want to do. So there's an attachment you can get for your aerifier that has these cone-shaped heads, so they don't go too deep and they kind of bury them right at the surface and you can fill with sand. That's one method. If you have worn out solid tines that are really short, you can set a very shallow depth and use those as well. But you can see it's not quite as effective as our slit seeding. So you tend to get these kind of patchy pluck marks of creeping bentgrass, and it takes a little bit slower to fill in. So this is not as ideal as a slit seeder where we're getting it into the canopy there. So one thing to keep in mind, if you can demo or rent or something, one of the slit seeders, that's the ideal way to go. So another thing that's been researched and looked at pretty extensively is green covers. So we can use green covers to increase our soil temperatures. So before we're able to get out there, maybe we want to put covers down and increase the soil temps before we seed. We can use it after we seed as well to improve the germination and heat up the soil. So different things have been used. The best, obviously, comes from those woven permeable covers. There's a couple different companies that sell them out there. Being in the northern climates, you may have access to some of these. If you're just patching a small area, you don't need a terrible amount of cover. There's been a little bit of work at the University of Nebraska looking at clear plastic sheets as well. So you can go to Home Depot, buy a clear plastic sheet in either 4mm or 6mm spec. But what you're going to want to do if you have the clear plastic sheets is you have to poke holes in the surface. So the work out of UNL suggests every 2-inch on center, poking a hole in there to get air movement through there. But you need to be real careful with the plastic sheets that you don't leave them on at high temperatures. You can get some solarization fairly quickly and cause some issues. And then finally, high rates of pigments can be used. I think their work at Nebraska suggested like a 4x or 6x rate of pigment to darken up the surface. You get subtle increases in temperature, but it's nowhere near as effective as these permeable covers. And then once the daytime temps reach about 70, we want to be cautious of leaving these covers on the surface. We can kind of burn up some turf and cause some more issues there. So be careful about high temperatures. So post-seeding management, this can be fairly important. We want to put a starter fertilizer down at seeding, shoot for roughly ½ pound to 1 pound per thousand of phosphate. We want to limit the amount of slow-release fertilizer in this initial application. We don't want too much tied up in water-insoluble or slow-release fertilizers. And then we can come back in with low-rate soluble N to supplement our nitrogen applied with the starter fertilizer. Obviously, the preferred form here would be nitrate, or potassium nitrate, ammonium nitrate. Urea is probably also acceptable, but going out at 1/10 pound every week or every 2 weeks to supplement our initial application. We want light, frequent irrigation during germination, typical of any kind of growing. Keep it from getting too dry or too wet. Mowing actually can be one of the more important things you do. So we want to do our first mow just as a rough gauge around 2 weeks after emergence. If possible, you want to use a walk mower, and you want a solid reel on the front of the mower. Wear and traffic from triplexes can really stunt the growth of new bentgrass seedlings. Just the heaviness of it can really cause issues. So if at all possible, walk mow. You want to get out there before the grass gets too tall. If you come in there and scalp off too much of the leaf tissue right away, we can cause issues with taking too much tissue off and then a lot of time to recover. So start somewhere around 1/4 inch to 0.02 or 0.2, and then we can lower the height by 0.05 inches a week. And that's just a rough estimate. Maybe it's growing a little bit better, you want to push it a little bit more, or it's a little bit weaker, you need to back off. So top dressing, we can apply light sand top dressing rates to kind of bury that organic matter at the surface and smooth the surface. But once again, until we get really established and form a good mat, we want to avoid dragging that sand. I don't mention herbicides or PGRs here. Obviously, we don't want to apply any pre-emerges. This would probably pertain to like fairway turf or rough turf. So before seeding, avoid any pre-emerge herbicides. And then with PGRs on putting greens, I would wait till you get a fairly good establishment of your grass on putting greens before you start applying PGRs. The goal here is to grow the grass and get it established and not maintain playability. So that's one thing to keep in mind. So we're running a little short on time here, so I'll briefly cover some cultivar selection and NTEP. I'm sure most of you are familiar with the NTEP or the National Turf Evaluation Program, but I want to touch briefly on that and point out some parameters that I would probably look at when selecting a bentgrass to replace any winter-killed areas. So this is the main homepage here. You have a statement that you have to agree to, and then you can get in. So one thing I want to talk about a little bit is there's a new statistical procedure in SAS. It's been around since 2009. The abbreviation is AMMI or AMI. So this takes into account our cultivar by location interaction. So how the cultivars respond in different locations, and then we group like locations together, and then we get these AMI groups. They changed the terminology in 2013 to location performance index, but these are basically locations where the cultivars within those locations perform similarly. So you just kind of have to go through the different groups, see which the local state, what group that local state is in, and then look at the overall mean for that local state. So we'll look at that a little bit briefly. The thing to note here is we're still able to look at our turf quality by state. So if we want to look at just the state that you're closest to, you can look at that. So here's the home page when we come in. So you've agreed to their statement. You come to the home page here, and we want to look at some data. So we'll click up here on the previous data tab, and it'll bring us to this page. And so we have it organized by cool season grasses on the left here, and our warm season grasses down below. And we're interested in putting greens, so we'll click on putting greens here, and then it'll pop up all the different NTEP tests here. So they were previously in 4-year cycles. Now we're in a 5-year cycle for NTEP, and we'll probably want to look at the most current one, although some of the varieties will have to look back to the older tests as well. So say we're interested in the newest data, so we'll click on the 2017 data, and it'll bring us to this page. So we have our table of contents. So these are all the different parameters we can look at. So turf quality, color, texture, density, spring green up, our seedling vigor, that's probably pretty important to us, and then our frost and winter kill. So say we're interested in seedling vigor, which ones grow quickly and establish quickly. So we click on that one, and we see our closest location is St. Paul, Minnesota. So we'll click on that test, and it'll pop up our data here. So this is our percent establishment in St. Paul. So they were seeded probably in September 2014. So we got an October rating and an April rating. We have our LSD values on the bottom. So that's our least significant difference. And then we have our cultivars here ranked by the average mean here for establishment. So with LSDs to keep in mind, that tells what is different from each other. So if we have, for Shark, for example, which is one of our varieties, is a 6.7. So anything that is 1.4 units below that or above that is statistically different. So if we go down to luminary here, that would be statistically different from our shark, which is at 6.7. One way to interpret that there. So we also probably want to look at turf quality, see how they perform. So we click on turf quality, and then here we have our location performance index groups. So if you're like me and cheated, you know we're an LPI group 3, where we see Minnesota. They perform equivalent to New Jersey and Missouri. So we can look at how they ranked. Piranha is another one of our varieties that performs very well. It's our newest variety and a top NTEP performer. And you can see the difference. So Pencross, which is one of the older varieties here, is all the way down the bottom with a very low rating. So just an idea for comparison of turf quality overall. And then finally, freezing tolerance and winter kill. There's actually no winter kill in the newest NTEP trial, so we got to look back to the 2008 NTEP trial. We can click on creeping bentgrass because that's what we're interested in, and look at a breakup of the different varieties. So Barracuda is another Mountain View variety that does very well for winter tolerance or frost tolerance there. So just a list of bent grasses that are available through Tessman that we provide. Piranha is our newest creeping bent grass, very high density, very fine texture. It's got great heat tolerance and a very good disease package. Barracuda is another great one, a low input creeping bent grass that has great drought tolerance as well as a good disease package. Shark is another good one. The main attribute here is it's very aggressive establishment and it's very competitive against POA. We've seen this used a lot in the upper Midwest where we have mixed stands of annual bluegrass and creeping bentgrass. And then finally, we have a colonial bentgrass called musket that has excellent brown patch resistance, which is the major disease of colonial bentgrass. So with that, I think we have a little bit of, I think we're pretty short on time, but I'd be happy to open up to any questions if anyone has any questions at this time.
Chaz, with all this winter activity going on, do you have a few minutes to talk about how to recovery from the massive amount of ice melt being thrown along the sidewalks and driveways and parking lots?
Yeah, yep. So when I was at Rutgers, we worked a little bit on the roadside work with the University of Minnesota that Eric Watkins was doing there. And yeah, the salt damage on the side of the roads can be very devastating and cause a major issue. So there's a couple things to do. So the first thing I would do is probably if you have severe winter injury on a roadside or the side of a road, I would look at getting a soil test right away. So see where the salts are in your soil profile and see where the different levels are. And typically if you send it to any accredited soils lab or a university soils lab, they'll give you recommendations for dealing with the salt and how much gypsum you need to apply, or if you've had a pH effect as well, how much lime to apply. And so it's very important to know which one to apply. Do I need to change the soil pH and increase the soil pH and get out of the acidic level? In that case, you would want to apply lime. You'd also supply the plant with calcium to kind of equal out your base cations. If your soil pH is okay, then maybe you just need to apply gypsum or calcium sulfate to replace the sodium, magnesium that's in the soil profile and get your calcium levels up. So I would start off with a soil test, send it in the lab, see what your EC levels are, see what the recommendations are, and then apply based on those recommendations. But the same would apply as far as getting rid of that organic matter in there and then prepping the site. And then if you can come back in with a slit seeder or anything like that, I think that would be the way to go. But the main thing is correcting those soil issues before you do any renovation to the site, because if you just renovate it and try to apply some grass seed down, it's not going to grow under those salt conditions. If you have really severe salt conditions and you see this being a repetitive problem, there is salt tolerant grasses out there. I would refer you to Eric Watkins' website on some of the roadside work that he's done. There's different options out there for even species out there to look at for salt tolerance. So There's a couple different things. Alkali grass has done very well on roadsides. There's different salt tolerant perennial ryegrasses or fine fescues that have done well as well. So he's got a plethora of data and some recommendations for different species to reseed into these roadside areas or salt affected areas. Any other questions?
Seeing that there's no more questions at this point, thank you to Dr. Chas-Smith and to you for attending. Just a reminder, this video will be uploaded to our Tessman YouTube channel. Thank you again. Have a wonderful rest of your day.